Terrestrial magnetism. A freely suspended bar magnet approximately points towards the geographical north with its north pole and the geographical south with its south pole as it comes to rest. This is also known as the directive property of a magnet. The direction in which a magnet points changes from place to place on Earth. Similarly, when a magnetic needle is pivoted at its center and allowed to a vertical plane along its north and south, it does not remain vertical but remains inclined to it. This inclination also changes from place to place on Earth. These observations prove that the Earth behaves as a huge magnet. Earth's magnet may be imagined as a giant bar magnet stuffed inside the Earth with two ends running between the geographical south. But the north pole of the Earth's bar magnet, called the magnetic north, lies near the geographical south, and the south pole of the Earth's bar magnet, called the magnetic south, lies near the geographical north. The effect of the Earth's magnet extends up to 528,000 kilometers from its surface. To know the properties of the Earth's magnet, one must know some quantities which are called elements of the Earth's magnetic field, which is studied under the name terrestrial magnetism.
Citizens of Quebec slept. No one knew that 93 million miles away, a menacing storm was brewing on the sun. A solar hurricane swept through space. 3 days later, it struck Earth. A magnetic storm quickly spread over the northern hemisphere, but the province of Quebec bore the brunt. Over 1 million amps overwhelmed the power grid. Power stations went down like dominoes, casting 7 million people into darkness. On the outskirts of Montreal, the Gombus family witnessed the blackout.
I was sitting watching television. It was around maybe 2:30, and a quick power surge just went off, and then it came back on, and then things just started getting dimmer. Like if everything had a dimmer switch to it, television, light bulbs, it just kept on getting dim, 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 and then it just stayed there. Looked at the light bulbs, the elements were glowing red hot, just the elements themselves, and even the house had a slight hum, like a light transformed. The whole house just had this general magnetic hum.
The blast that knocked out Quebec's power was in fact a potent kind of solar storm that had been discovered only recently. In the 1960s, a team at the Naval Research Lab was perfecting a new instrument to look at a part of the sun only visible during eclipses. Usually not seen by the naked eye, the surrounding corona had long been an enigma. This blazing halo might bear witness to the sun's violent nature. The team figured out how to simulate eclipses, allowing them to view the corona on demand through a novel instrument called a coronagraph. Don Michaels was an astrophysicist on the project.
Basically, a coronagraph is just a small telescope. You point it right at the sun, but you don't want it to be blinded by the sun, so you make an artificial eclipse. You do that by taking a black disc and holding it out at arm's length in front of the telescope. So now the sun's blocked out, and you can see the corona around the sun.
To work well, instruments needed to be in space, above the veil of Earth's atmosphere. After World War II, solar science entered the space age at White Sands Missile Range. Captured German V-2 rockets lofted instruments to record the sun, the first ever views from space. But getting the film back was another story.
And all they ever found was a big hole in the desert. Never found any pieces of the actual rocket, whether it buried or exploded or what. So the first lesson is don't let an object fall from 100 miles above the Earth, straight down, streamlined.
When Don Michaels joined the rocket team, he helped them with a key advance. A coronagraph was put into orbit. Images were then transmitted back to Earth to be reconstructed on black and white Polaroid film. The satellite soon delivered a dazzling surprise.
We saw pretty much what we expected.
No one had imagined that the sun could fire off such massive blasts of particles. What they had seen, now called a coronal mass ejection, or CME, made the scalding solar wind look like a gentle breeze. The discovery took the scientific world by storm. No one knew what these events might do to Earth, or how common they might be. To find out, a space station called Skylab was launched in 1973. The first manned orbiting laboratory, its instruments kept the sun under close watch. A clear picture of the sun's violent nature was beginning to take shape. The mission was recording on average 1 coronal mass ejection every other day. The discovery of CMEs was alarming. Space exploration was then in high gear. No one had suspected that astronauts on earlier missions could have been exposed to danger.
If you look back in old textbooks, you see that the Earth is there in space with the Earth's magnetic field extending outward into space forever. No hint that there's electrons and protons. No hint that there are high-energy particles from the sun. But when the first spacecraft were sent up, it was discovered that the space environment around the Earth is not benign at all. The August 1972 solar storm event was very, very severe. It was the most severe of that part of the solar cycle, and it's been one of the most severe of the last 2 or 3 solar cycles. And the high-energy radiations was such that the astronauts, if they had been en route to the moon at that time, could have had serious radiation sickness and perhaps could have been killed by that radiation. It was so intense.
At the dawn of a new millennium, construction of the International Space Station began during Solar Max. The mission will expose more astronauts to the sun's dangers than ever before. Braving frequent spacewalks, astronauts put their lives on the line. NASA has taken special precautions. The space station will have a heavily shielded room at its core where astronauts have a chance of riding out a solar storm. Astronauts may be at risk, but they will get warnings. Down on Earth, there is no place to hide. At the height of Solar Max, as many as 6 CMEs are discharged by the sun every day. ground-based telescopes like Big Bear Solar Observatory are ever on the watch. Boasting one of the largest solar telescopes in the world, Big Bear is one of our best early warning systems, alerting us to the magnetic forces thought to trigger a solar blast. Detecting a coronal mass ejection aimed at Earth is difficult. An even greater challenge is predicting a CME. Researchers are learning to read the telltale signs of a coming eruption, from changes in the magnetic activity of sunspots. But from the ground, we can only watch the sun during daylight hours, and even then, only when not covered by clouds. To watch for solar danger around the clock, the place to be is space.
5, 4, 3, 2, 1, ignition, and liftoff of SOHO and the Atlas vehicle on an international mission of solar physics.
Launched in 1995, SOHO is the only spacecraft that can monitor our star 24 hours a day. A collaboration between the European Space Agency and NASA, SOHO views our sun in both visible and ultraviolet light.
Okay, so run this one until 1800, then after 1800 switch to the LEM.
As I understand it, the reason why
A stream of data and images is beamed down to the Goddard Space Flight Center in Maryland. Space weather has become a global concern.
Hvordan strålingsdosene på fly målt på Concorde og også ulike fly.
Pattern there is...
It's caused by the optics and trace?
Rainer, hast du den Flare schon gesehen?
The SOHO spacecraft is basically our eyes on the sun. It focuses constantly on the sun 24 hours a day, taking images. The reason that that's important for us is if you go away and you come back again, you've missed so much because things are happening all of the time. So it's very important that we keep looking at it constantly.
SOHO orbits at the point where the gravity of Earth and Sun are balanced.
And this is 1 million miles out. Now the sun's 93 million miles away, so it's not that much closer to the sun than we are. Things happen on the sun. We're seeing the activity, the dynamics. And I think that's the biggest breakthrough. That's the big, new, exciting thing about SOHO is that you're seeing the thing fly.
A communications satellite is hit. Although its orbit doesn't change, it's suddenly left outside the Earth's magnetic field. Spinning in place, it loses its bearings. All contact is lost. Without its protective shield, the satellite is now exposed to a direct hit from the blast. Killer electrons bombard vulnerable circuit boards, building up a dangerous charge. The satellite is literally fried. But the greatest impact might be felt on Earth. A solar burst could silence radio communications, leaving the military open to attack. Planes flying at high latitudes might be bombarded with radiation, exposing passengers to the equivalent of 100 chest X-rays. Pilots could lose radio contact with air traffic control. And with thousands of planes in the air at one time, the results could be deadly. With weather satellites out of commission, hurricanes wouldn't be seen coming. Our busiest cities might suffer the worst effects of the solar storm. ATMs could crash, pagers go silent, long-distance phone calls become impossible, and perhaps the ultimate nightmare comes to pass. Your cell phone goes dead. Today, we get only a 1-hour warning before a solar blast strikes Earth. Can we do better? An answer may lie in our own backyard.
Here, let's fiddle with this box. We connect those two in there.
A boy playing with rockets may not be our solution to solar science, but not every kid has a rocket scientist for a mom.
5, 4, 3, 2, 1, 0, ignition!
Lika Guhatakorta is program scientist of one of NASA's most ambitious solar expeditions. Scheduled for launch in 2004, the Stereo mission will send twin spacecraft to view the sun from 2 different vantage points. It will take a 3D look at our star and help us measure the speed and direction of a CME.
Stereo, for the first time, will be sending 2 spacecraft that will veer away from the Sun-Earth line to get 2 different perspectives on the sun. And
the cold, dark vastness of space is warmed and illuminated by stars. Some may be better behaved than our sun, others more unruly. But our planet's fate is bound to our daytime star, for better or worse. We literally live inside the extended atmosphere of our sun. So we must continue to study its moods.
the sun is a star we live with. And in this technologically driven society, if we really don't understand the sun-earth connection, I think we are at a loss.
What we should be doing is to anticipate as much as we can potential effects. Then we should try to learn as much as we can about the sun during this solar maximum and the Earth-space environment so we can plan for the next one.
This solar maximum is really very exciting for us. We've got the most spectacular observatory in space that we've ever had. And we have lots of observatories on the ground. We're going to be able to look at it this time and see what's going on in much better ways than we've ever been able to before.
I don't think scientists really fully understand yet the true nature of the sun. It's one of those that the deeper you look, the more questions you come up with. And it's almost like this mystery. The deeper you probe, the more confusing and the more mysterious it becomes.
The sun will continue to nourish our planet, rising, setting, drenching our land in light and warmth. But our star, the only star whose face we see, is temperamental. We are beginning to discover its real nature.